In 2015, Julius Diego threw a javelin about 93 meters, and what we want to find today is how high that javelin reached. So from the computer lab, we learned that 45 degrees was the optimum angle to launch a projectile if you're going for a distance. So what I've drawn here is a vector triangle with 45, 45, 90 angles. And what we know, since it's a special triangle, is that the sides are x and the total velocity would be x root 2. What we have to find first is x. So using the vertical velocity, we can go x over 5 equals t for velocity, or for acceleration of gravity, which is 10. So divide by 10 times 2 because both ways, up and down. And then what we know is that it travels 93 meters, so we multiply time, which we have as x over 5 times the horizontal velocity equals 93 meters. And what we do now is solve through this, so we get x squared equals 93 meters, x squared over 5. Get rid of 5, so x squared equals 465 meters, square root both, so x equals 21.56 meters per second. So now we know that this x, the vertical and horizontal velocities are 21.56 meters per second. Now that we have x, we can go back, plug it back into x over here to find time. So 21.56 equals t, and what t comes out as is 4.312 seconds. But since we're trying to find the maximum height, which is at the vertex, which is in the middle, we have to divide that by 2. So our new time is 2.156 seconds. And what we can do now is plug this into a position equation. So y equals 1/2 acceleration gravity, or time, and then initial velocity, and then multiplied by time again. And what we end up with is the position at 2.156 seconds is 23.28 meters, which is the maximum height.